Good morning, good afternoon, or good evening, depending on where you're located, and welcome to our fourth annual Energy Storage Conference, Trends and Developments in Australia. We thank you for joining us today. All attendees will be muted throughout this event. If you have any questions, we ask that you please submit them by clicking on the chat icon on the right side of your screen and typing your question in and submitting it. Questions will be addressed by our panelists. And with that, at this time, it is my pleasure to introduce our moderator of the event, Luke Westmore, a partner at K&L Gates out of our Melbourne, Australia office. Luke, please begin.
As Grant just mentioned, my name is Luke Westmore. I'm a partner at K&L Gates in the Melbourne office in Australia. Absolutely delighted to be able to host an event with our esteemed panelists, Joseph Tadich and Garth Heron. So Garth is from NEON and Joseph's from Tesla. We are actually alumni from Roaring 40s, which was one of the first large-scale renewable energy companies in Australia. And so we've worked on many amazing projects over the years. I think it's fair to say, over a decade ago, when we were all Roaring 40s, large-scale wind was really the only show in town, really, in terms of the renewable energy market. But we're seeing over the last 5 years an absolute dramatic shift from large-scale wind really to now massive solar projects, and that has created many challenges, but also presented some amazing opportunities in the energy storage space. So, one of the huge challenges which this abundance of renewables has caused is grid issues, and we're now seeing a change in technology being used to help stabilise that. And Joseph and Garth have worked on some amazing projects over the years to do that. So I'll just hand over to Garth first, and then to Joseph, just to introduce yourselves, and then be really looking forward to having a great chat about some of the amazing projects that you guys have been working on over the years. So over to you, Garth.
Thanks, Luke. Look, Garth Heron here. So I head up the development team for a company called NEON here in Australia. We're quite a large international independent power producer, and in Australia we are the biggest in the country. We've currently got just over 1 gigawatt of operational renewable energy and battery projects across the country, but we've already committed to 4 gigawatts. So we're growing very quickly at a rate of about 1 gigawatt a year, maybe even a bit higher here in Australia. Look, really happy to be here, obviously with Joseph and Luke, but Joseph and I, of course, have worked on what was the biggest battery in the world, Hornstar Power Reserve, just 3 years ago. Now we're moving on to bigger and better batteries. So maybe Joseph, you want to talk about yourself a bit?
Yeah, thanks Garth, and thanks Luke for the invitation to present. I'm looking forward to the next hour or so. Yeah, so I lead the engineering team in Asia Pacific for Tesla, and both on the residential side and on the utility side. So on the utility side, really the focus has been over the last few years the introduction of the power pack system, which is what we did with NEON, which was at the time the world's biggest battery. There's always, these titles are very, very transient in my experience, and that's really a testament to how fast the industry is moving. So the world's biggest battery, Hornstar, 100 megawatts. We then did an expansion on that to 150 megawatts. We've only finished that just recently, but started last year, and then we've got some recent announcements with NEON on is it the world's biggest battery? I'm not sure. It depends how you measure what the size of the battery is, but the Victorian big battery, the 300 megawatt system. And just as a macro level, I think like my early days was in the wind industry with Luke as well. And in the early days, we were constantly seeing the cost of wind energy dropping. It really is a function of those big rotors coming into the market. And I remember early on when the first V90 came out, which the V90 now, the 90-metre rotor doesn't sound that big, but there's a lot of commentary in the industry saying this is kind of the limit. We kind of hit the limit. The rotors aren't going to get any bigger. Wind energy, cost of energy is plateauing. Well, we're seeing the same in storage now. So I've seen just in the last 5 years, I've seen a drop. Probably every 3 years is almost halving on the cost of energy for storage, and that's really a function. And in wind industry, it's the cost per megawatt hour, but in the battery industry, we're talking about really the cost, the dollars per kilowatt hour for install. And so what's happening is we're increasing the energy density of the system, which is reducing that cost per kilowatt hour. And what that's doing is we're starting to see parity in the grid, the same way we saw the wind industry early days when it just started. Once it got past that inflection point, wind was away. We're now seeing the same with batteries. We're seeing that cost per kilowatt hour at that point now where it starts to operate in the market and is competing quite successfully with traditional open cycle gas turbines, which is the traditional competition for storage. Yeah, that was thanks, Westy.
No, that's okay. Actually, you make a really interesting point about the cost of energy coming down. And one of the things I wanted to ask you guys about was how the Hornsdale project really came about and how it evolved, and how it's really helped with the grid and also the economics of the project. So I suppose there's a few questions in there, but getting back to how it actually started and any the success would be good to know, Garth.
Do you want me to start, Joseph, and then maybe you can add some colour?
Start, for sure.
Yeah. So like many things in the energy industry, the battery project probably started with a disaster to begin with, and the disaster in particular was a big storm that went through the state of South Australia, and it took out many of the very large power lines across the state. But it emphasised, I guess, the state's vulnerability to power outages and power blackouts. And there was a lot of chatter amongst the various governments about what to do about it. And then, of course, that famous tweet from Elon Musk, which basically said, well, I can solve the problems with a large battery in South Australia, and I can do it in 100 days. It led to a procurement process from the state of South Australia, and both Neoen and Tesla, I think, separately originally participated in that procurement process to build a battery for the state. And through that process, we recognised that we had a site in South Australia ready for a battery, and Joseph had a battery ready for a site. And so as that process moved forward, we basically ended up cooperating in the second round, I think, and the rest is history. We were competing against about 100 other companies that were looking to do a big battery in South Australia. I think we put together the most competitive tender in that process and won it. But then we had to deliver, and we did in the 100 days. Joseph?
Yeah, well, I was just going to ask Joseph whether anyone discussed whether internally that 100-day time frame was going to be achievable, or.
Yeah, I think sometimes in life when you have stretch targets like that, it's important just for everyone to work towards hitting it rather than analysing. So basically, the date we had, we worked back from that to see how logistically we could meet that. And in the end, we actually ended up having to air freight some of the equipment, which is so some of these units were a couple hundred kilos per unit. We were air freighting a lot of those systems through to site. So that was quite an exciting period. But I think technically at Hornsdale days, I mean, this was 2016 was what really knocked it off, and this was the SA blackout. And I think there was a lot of discussion regionally within South Australia on the power system and power system security and how that worked with the NEM. And I think due to a couple of things, like due to a lack of investment signals in the market for traditional scheduled generation, and really fundamentally the increased cost of putting scheduled generation. So scheduled generation, dispatchable generation, like traditionally thermal systems. So, and the cost of that was really not making sense in South Australia because ultimately it was competing with wind and now solar, and the cost of energy there is so cheap, and it makes it very difficult for these dispatchable units to get up. And this is what led to ultimately the system black in 2016. So what the Hornsdale project originally solved was to provide a 100 megawatt battery as a scheduled generator ready to be automatically controlled by the market operator for the network support, and that's fundamentally the interconnector between Victoria and South Australia, what they call the Hayward Interconnector. So when that's under stress, i.e., there's a lack of renewables in South Australia, or a lack of scheduled generation, we bring a lot of that power in from Victoria, and so what that does is network support systems, they operate very fast to change the power flows so that the transmission lines don't get overloaded. And one of the great benefits of batteries are that they can operate so quickly. So less than a second, like most batteries can go from 0 to full power. And that's just unheard of in a traditional thermal system. So typically, like a fast start in the thermal generation system is like 15 minutes to get on, and then it's kind of maybe another 15-minute ramp up. So these are the magnitudes, the orders of magnitude. We're talking 3-4 orders of magnitude difference. And the other benefit or driver in the South Australia at the time was the FCAS market. So in Australia, there's an energy market and there's ancillary services markets, and one of those is for frequency control. The FCAS market was being driven by a lack of supply of generators, because typically only thermal generators can provide that service. And what ended up happening was the price of that ancillary service was hitting the regulated max, which was causing a hell of a lot of distress to customers and to generators in South Australia. So what the Hornsdale project was designed to do was to sit there and to balance that market out and provide competition to that market, and it did. And there's been numerous financial analyses of that showing that the benefit purely on the FCAS regulation market was multiples of the cost to the state of paying for that capacity payment. So the return was a bit of a no-brainer. So yeah, that was an exciting time on the 100 megawatt system. And looking back now, 100 megawatts doesn't sound so big now actually, but it just shows how quickly the industry's moved.
Luke, I think you're on mute.
Sorry, thanks, Gus. Yeah, that was really interesting to speak about the drivers of how that all came about with that catastrophic event. But have there been any kind of unexpected upside consequences of the Hornsdale battery, and any lessons that can be learned from that for other markets, not only within Australia but Asia Pac and globally?
Yeah. You talk to commercial side, Garth, and then I'll talk to some technology stuff.
Yeah. So look, from a commercial side, that battery, when we got into it, we were not 100% sure on how it would do commercially in the network. And the reality is, I think for a battery in Australia, and probably in many of the other markets as well, is that you can't do a single thing with a battery and expect to make a return on it. What we found is that it's actually the combination of services and participation in the market that leads to a good financial outcome. And probably more than anything, what we learned through Hornsdale Power Reserve was that the market actually changes when you enter the market for a start. So we pushed down the cost of frequency control and ancillary services with Hornsdale to about a third of what they were before we entered the market. And that's a big part of revenue for the battery. But as you can see, on that elasticity, when we entered the market, we actually pushed the revenue available down from the whole of market. So the markets are quite shallow in terms of what the battery's participating in, which means that they're very sensitive to how you operate the battery. And look, it's really about in terms of getting a good outcome from a battery, it's about balancing up all of the different revenue streams that are available to try to pull the battery into a profitable position. And those revenue streams change over time. Like over the last 3 years, the way we were dispatching the battery at the very beginning is very, very different to the way we dispatch the battery today. And we've earned different revenues from different parts of the market all the way through the 3 years.
So how is that? How's that evolution work out? That's actually really interesting. That I suppose for a fixed asset, you're continually working out different ways to make revenue.
Yeah, so there's kind of two aspects to it, I guess. We've been working with Tesla on the control system for the battery, which automatically comes up with the best bid across the energy markets in Australia. So in Australia, we have electricity markets, black electricity markets buying and selling, but we also have some frequency control and ancillary service markets. And the battery is constantly optimizing across those as we go forward. And the optimization obviously changes depending on how the market responds to our participation.
Yeah, excellent. And Joseph, just moving on from that, I mean, I suppose that's the commercial benefit, but from a technical point of view, there's been a lot of discussion about how the batteries help stabilise the grid. It'd be great to hear how that's happened, and how we might be able to use that across the broader network.
Yeah, sure. So I think, look, at the start, in the early days, like when the contract was announced and we were under the construction phase, there was a lot of skepticism, I think, in the industry on batteries because it was new technology, hadn't really been proven, at least in the Australian context, at that scale. Like I know, we all remember the comments on the big banana and the giant prawn or whatever it was, and how it could only provide 15 minutes of the Ninja Warrior contest for backup systems, right? But I think the actual application of the technology wasn't really understood at that point. So when we went through the full detailed design, the grid connection with the AEMO, the market operator, and went registered in the market and provided those initial testing required to participate in the market as a scheduled generator. I think I think everyone was pleasantly surprised at the flexibility and the speed of the response, particularly for the energy market. So scheduled generators in the energy market basically follow dispatch control from centralized dispatch, which is the AEMO, and the same in most markets in the world. And there's something called an AGC, which is an automatic generator control signal, which basically every 4 seconds updates where you got to be. But I think what AEMO was very pleased with was just how accurately and how quickly we followed that signal. So what that means is batteries provide a much faster and a much more accurate speed of response to the AGC. And what that does is that allows the FCAS, or frequency control regulation, to operate in parallel with the energy markets. And what that does, to Garth's point, was you can co-optimize. So what we call co-optimizing. So in the energy market and then the frequency control market, there's about eight frequency control markets operating in parallel. So all of those markets, the batteries are operating at the same time, and they're operating in parallel. So what that means is you're optimizing the revenue 24/7 for the site. Now, and so the third contingency market or ancillary service market is called the FCAS contingency market, which is a high-speed market. We have to respond pretty much autonomously to a change in frequency. And a change in frequency changes quite a bit normally, but once it goes outside normal bounds and it starts to drop or go too high, that's when this market kicks in to arrest and stabilize the grid. Now, and what we've found throughout the commissioning and throughout the operation of the system is just how fast and accurately we respond on the contingency signal. So as the frequency drops, we automatically compensate for that. And there's quite a few contingency events in South Australia due to a combination of things, but primarily have been due to trips of some of the aging thermal generation. So as those generators drop off, so they can be 200, 300 megawatts of generation that just drops off instantly and their frequency droops. In that scenario, the battery automatically compensates and to stabilise that grid. And there've been quite a few scenarios where we've swung from charging to discharging in less than a second to stabilise that network. So it's been, I think, the flexibility has been demonstrated, and now that the proof of concept's really been there at 100 megawatts. I think now we're seeing that wider rollout in net grids, not in Australia, just globally, right? And that's really what led to then the expansion of the Hornsdale from 100 megawatts, 150 megawatts, because it was recognised that just how well it's been performed. So the next bit is why not expand it and operate it, put more energy in it, put more power in it, and that's where we are now with the Hornsdale system.
Yeah, and maybe just to add some, sorry, Luke, just to add some headline figures to all of that. So in terms of the savings for customers in South Australia since the batteries come in, it's saved in the order of $50 million a year in the 3 years that it's been operating. And that's already paid for the cost of the battery 1.5 times. If indeed those savings were just going straight into CapEx for the battery. So the payback period for energy consumers is extremely short. 1.5 summers, and you've paid for a battery in terms of giving back to energy consumers and lowering pricing. And then the other really interesting headline figure, I think, from that discussion is how often we bid into the national electricity market with the battery. And over the last 3 years, we've done about half of all the bids in the whole network just from this one battery. So because it's participating in eight FCAS markets, two energy markets, and it's constantly adapting and to those markets, it's bidding at a frequency that no one's ever seen before.
Yeah, that's amazing. And so the expansion was completed this year, and so it's gone from 100 to 150 megawatts. So I mean, what an amazing project.
Correct. Yeah, and so one of the things that the expansion really provides is it increases the depth of the energy market. So typically early on in the industry days, it was really a focus on high power for small, short durations. But what we're seeing as we've increased the renewable penetration, and this is in South Australia, we're seeing that the depth of the energy market, so the times in which it's negative and the times in which it's above at high prices and above $300 a megawatt hour traditionally, they're increasing, right? Which makes sense because we've sometimes got periods of high abundancy and which drive those negative prices. And for a battery, a negative price in the NEM means that the battery will charge and actually get paid to charge. And in fact, there were periods earlier this year where we made more money charging the battery than we actually did discharging the battery, which we'd never modelled or expected, but it was a pleasant surprise. But we can see that intuitively as increased renewable, particularly residential solar, is increasing. So during the day, we are seeing that negative pricing coming through in SA as well as Queensland, and even this year in Victoria, which is the first time I've seen it really coming through. And as we've got the utility scale wind and solar coming through, and it's really a displacing energy because it's the thermal generators can't really compete at that cost. We're getting that marginal cost of energy being pushed down. So in those scenarios, we expect the batteries to be more batteries to be able to charge that up. And then when in the peak, when those peak power prices hit, the battery can then discharge basically the free renewables which they had just charged.
Yes, I mean, there's also been a lot of talk in the market about having a requirement for base load power, and the fact that renewables don't necessarily provide that base load. But obviously, South Australia has a massive penetration of renewables. I mean, you guys have seen it firsthand. Would it be fair to say that batteries will effectively help the argument that renewables can effectively provide baseload power over the next 20 years or whatever it might be?
Well, Luke, we're already there. Like, the funny part about this is that when people talk about baseload generators, they usually don't come in with the understanding that our so-called baseload generators really have somewhere between, say, 60% and 90% availability anyway. So there's downtime associated with every generator in Australia, whether you're thermal or you're wind-based or you're solar-based. And Neoen, we've moved to selling firm contracts from our portfolio, and what that means is that we're able to now mix together the dozens of projects that we've got in operation, and we're able to sell 24-hour power supply to customers, and the batteries form a big part of that equation. So batteries are filling in the gaps for us. They're also allowing us to take these market positions and sell firm power from our wind and our solar. And if you look at our portfolio now, we've got a pretty even mix between wind and solar and batteries here in Australia. And I think this is probably the future for probably all renewables in Australia, moving away from the PPA model, where you just sell energy when you can make it, and selling nice firm contracts that go for 24 hours a day for the big industrial customers.
Yeah, no, it's really interesting insight. And Joseph, I mean, obviously Tesla is a global organisation. What are you seeing globally in terms of storage with your kind of product, and how that's helping different markets?
Yeah, sure. So in a global context, so we do the residential program, which is the Powerwall program, as well as the utility scale program. But we're seeing, roughly, very roughly like a 50-50 split in those markets, both as consumers opting in on high solar penetration markets like Australia in the Southeast States and Queensland and WA, as well as in the US, and particularly in the Southwest, where the high solar radiance is that residential solar is so cheap that the economics now making sense to store that energy in a residential battery rather than and to then power your peak loads as the sun goes down, rather than buy that off the street utility, right? So that's what's driving that residential market, and that's been an incredibly strong growth for us over the last 5 years since we introduced the Powerwall program. On the utilities scales as well, we are seeing definitely a switch, and the US market is driving this, and that's really been driven by some of the mandates they're having on the state utilities to provide 4-hour battery systems to replace the open cycle gas turbines, so the peakers in the US, and a lot of that's coming down to the economics of the battery storage is more economical now than to build a new gas turbine, or at least an open cycle gas turbine, because closed cycle is a 24/7 base power, but for open cycle generation, we're seeing that competition coming through. And that kind of started happening 2 or 3 years ago in the US. We're now seeing it happening more so in Europe now, as well as through untraditional markets such as in Africa, where a lot of the time they're just skipping the whole idea of having a centralized power system and having distributed microgrids with solar plus battery storage to replace those networks. So yeah, we're seeing a wide scale rollout of energy storage and pretty much in all markets, I would think. And also in Pacific Islands, a lot closer to home here, Pacific Islands has been a massive boom in microgrids and solar, and that's traditionally displacing some of the high fuel costs of diesel gensets, which has traditionally been a source of island power. So American Samoa, Western Samoa, all of these now displace the traditional diesel gensets, and due to high cost of shipping diesel to these remote islands. I think it's a trend we're going to continue to see, and it's going to be exacerbated by increasing renewable penetration, as I mentioned before.
Yes, and that's really interesting about the US. Battery kind of almost supplementing gas generation, because we've been, I suppose the federal government here has been talking about a gas-led recovery. How do you see the economics of renewables with battery versus the renewables of gas at the moment? Maybe that could be one for Garth.
Yeah, look, Luke, it's probably no surprise to hear that I think renewables and batteries are by far the cheapest way to make power in Australia these days. Gas has been our peaker in Australia for a long time and often sets the pricing point in the market. That's changing. That is changing. So more often now our batteries and our renewable energy projects are setting price in the market. It's at a lower price than gas can dispatch at, which is why when you look at the figures over the last couple of years, you've seen renewable penetration going up substantially in Australia. Over the last year, for instance, solar rooftops went up another 50%. Large-scale solar went up 100%. And in that time, you've actually seen gas market share fall slightly. So the narrative that with more renewables you need more gas just doesn't seem to be holding true in Australia, although it's something that's used politically. It's actually not coming through. And you can see from the numbers over the last couple of years, gas penetration is falling while renewables go up. I think batteries have played a big part in that. They're helping to bridge those gaps and basically provide 24-hour power at a price point that you can't do with open cycle gas.
Yeah. I mean, there obviously seems to be a bit of a split between the federal and state governments. Like most of state governments are going alone. We saw last week New South Wales outlining their renewables roadmap. Victoria's got their own renewable strategy, which is a bit of a nice segue just to talk about another project which through Britannia actually was announced last week, which is the Victorian government battery, which you and Joseph won the big four. As far went on to sleep, but you guys worked very closely on that, and yeah, it'd be good just to get an overview of background to that project, rationale behind it, and next steps.
Yeah, you start, Garth, and I'll jump in the detail.
Yeah, look, this is a really exciting project. It's the 300 megawatt Victorian big battery, and one of the biggest in the world, maybe the biggest in the world, sort of up for debate. But the interesting part about this project is it's again something that's come out of the Hornsdale Power Reserve. So as part of the Hornsdale Power Reserve, we looked at providing support for the Interconnector, as Joseph described earlier. And that's through a System Integrity Protection Scheme, or SIPS scheme. And based on what we did there for South Australia, the Victorian government was looking at ways to improve their interconnection with other states, and in particular the interconnector with New South Wales to the north of Victoria. And one of the ways that a battery can help is through one of these SIP schemes. And essentially what it does is it takes away the need to run headroom on your interconnector, and you have your contingency response coming from a battery instead of coming from spare capacity that you have to hold spare in the interconnector. So it allows much greater flows to go between states, and that has a 24-hour a day kind of effect on electricity price and pushes price down for consumers. So the Victorian government launched this tender last year for a very large battery to increase the headroom available on the existing interconnectors with New South Wales. We participated in this process for almost a year, and we're again awarded this project actually at the beginning of November. And now we're in construction on this 300 megawatt battery. So it's the technology is very similar to what we did at Hornsdale supporting the interconnector, but it's probably one step further. The response in terms of interruption to the interconnector is a little bit more complex than what we used at Hornsdale. The effect is the same. You know, we're increasing headroom on interconnectors, which allows more electricity to flow between states and pushes the price down.
Yeah, so Garth, you mentioned it's under construction already. You know, from a lawyer's point of view, interested in how your kind of contractual structure in terms of how you've been delivering these projects. With Tesla, obviously, you guys as the principal. But is it a fully wrapped EPC or?
Yeah, we like fully wrapped EPCs, and Joseph likes taking on all of the aspects of the project. So yeah, it's fully wrapped. Most like most of our projects. But you know, there's still a lot of things that we need to do as the owner and operator of the facility and the developer, and ultimately for us, it's just about us sticking to what we do really well. So in terms of the structure, you've got Neoen doing most of the permitting for the project and getting the project ready. There's of course the deal that we have to do with the transmission network service provider, which is done by us as well. And then we have Tesla coming in and wrapping these projects, constructing them, bringing in all of the subcontractors that are needed, and ultimately delivering a turnkey battery for us.
Yeah. And Luke, I'll just add that there are some nuances in the battery industry on EPC, and part of the driver for the EPC wrap is that the scope split, so the amount of dollars which are spent on the battery system relative to the whole EPC is quite high, right? We're talking like probably 80% of the scope is the battery cost. So the percentage of the actual balance of plant and the civils, and which are relatively minor compared to a large wind farm or even a solar farm. And if we dig into that, we find like the battery scope. So Tesla, we are highly vertically integrated. So that means we manufacture the actual cells themselves and the battery modules and the mechanical holdings for that, the cooling system, the inverters, everything's manufactured in-house. So not a lot of subcontracting that goes on by Tesla. So if you compare that to like solar industry, where it's a very different industry because there's lots of different players. There'll be a panel manufacturer, an inverter manufacturer, transformer manufacturer, civils, electrical. All those scopes are relatively small, so it's hard. So the OEMs like SMA only have like 5% of the contract value of a solar farm. So it'd be almost impossible for them to do an EPC wrap on a whole solar farm. Wind industry is probably more like the battery industry because the OEMs wrap all of the turbine. In the old days, they used to have people making blades and towers and nacelles and trying to wrap and get it on site. But nowadays, it's pretty much that model solidified, except the balance of plant on a wind farm is probably more balance of plant percentage-wise than on a battery. And so then when you get into the performance guarantees required on the site through the EPC contract, the natural model is really kind of trending towards this EPC wrap of the core battery system, and I think that's probably a trend that will continue. Although there are battery integrators who purely just do the integration, and so they'll buy batteries off X and they'll buy an inverter off Y, and they'll do the cabling and the integration themselves. But that's also a very challenging model because if your scope's only 10%, it's hard to take 100%. Contractual liability in performance guarantees on an EPC contract. So there's some of these external drivers which are pushing the market towards that.
And what's the Victorian government's I suppose driver in terms of this battery? Where are they hoping to get at it from a technical point of view?
Yeah. So I think there's a couple of drivers. The first one is the interconnector flow. So same as in South Australia with critical interflow is the Hayward interconnector between Victoria and South Australia. in Victoria, with our critical interconnector is the 330 kV connection between Victoria and New South Wales, which is we call the Victoria New South Wales Interconnector. Not very imaginative, but the VNI, and that's basically links up the Snowy Mountain scheme up in the northeast down to Victoria, and so what the driver for this is. As we increase the renewable penetration in Victoria, and the Victorian state government's got a great ambitious target of 50% renewables by 2030, and I think it's 100% renewables by, I think Garth, you probably know more than me, I think it's 2050. So these kind of targets, these aspirational targets to hit. Yeah. So
2050.
2050. Right. Thanks, Garth. Thanks. And so some of the challenges that it has for a market operator is that you need to design the system such that it works any time of the year. So in those peak demand days, and particularly in Melbourne, we have those in Christmas, before Christmas, we have those kind of hot northerly 40, 45 degree days. We've got traditional.
That's degrees Celsius for those overseas.
So like 100. Was it 110, I guess? 110?
Over 100, yeah.
Yeah, 110 Fahrenheit or so. In those scenarios where you need to be operating the system in a stable state. So if in that scenario renewables are down because for whatever reason it's a low renewables day, and we have the thermal generators under stress. So and that happens when you're getting above that temperature, that particularly the steam, the coal steam generators start to strip off, and there's usually every month or so we have a trip in Victoria, and that in summer that increases to every couple of weeks. So in that scenario, if we do lose generation, and so what happens at the moment is that's balanced from New South Wales. We just draw that extra power in from New South Wales. But as that interconnector to have that safely operate within limits, we need to operate it in a contingency environment, which means you can have a network failure anywhere along the path, and you can still be, the thermal limits in that line are still okay. So what this does is it allows you to operate that interconnector at a higher power level, because you know that if a contingency has happened, you've got 250 megawatts that will instantly come up and compensate that in the event of a thermal generator trip or a line contingency. So what that means is you can have a higher percentage of renewables and less reliance on thermal generators in the system. And this is something we're going to see, I personally think, in lots of jurisdictions, Australia and overseas, as we have more increased renewable penetration. That will force early retirement of traditional scheduled generators, thermal generators. So having the battery systems there as a scheduled generator to allow for that is going to be key to accelerating the transition to renewables.
That's right, and more renewables run the interconnector harder, right? I mean, that's the other big point here. Yeah, so I mean, it's an interesting segue into talking about maybe the future of the market. Like Neoen and Tesla are both big companies with the opportunity to invest really kind of globally anywhere they like. Neoen has obviously done a lot of projects here, as of Tesla. So Garth, what do you guys find attractive about the Australian market? And you mentioned you've got a 2.4 gig pipeline. You're obviously confident that it's a good market to invest in for the long term. Yeah, so absolutely. I think Australia, to me, is it's a really interesting market in a lot of ways. We have a fairly small market from a world sort of point of view, but it's long and stringy, which makes it quite technically complex and interesting. But we've also had a period of time where solar rooftops and energy efficiency haven't led to a lot of growth in terms of megawatt hours needed in Australia. But the megawatt peak that is needed to cover the peak times is continuously climbing. So we need really flexible energy solutions in Australia. As well as the need, of course, to decarbonise, because we're still running 70% of our energy or roughly thereabouts from coal. So those coal power stations, they're all going to shut down in the next sort of 20 to 30 years. Obviously, we need to replace those. And strangely enough, we actually need to replace them with something a lot more flexible, just due to the changing environment here with consumers, which means we've got to install a lot of new equipment, and we've got to invest. So Neoen's been investing big time in Australia. We're looking at putting about $1 billion a year into the country. And like I said, a very even mix, I think, at the moment between wind and solar and electricity storage. And I think the future is exciting as well, because with all of this renewable energy, we're going to have days where we've got lots of excess power that's just about free. And that opens up a whole bunch of new opportunities in terms of how to package up excess power across Australia into something that can be exported. So I think the exciting parts are, meeting the demand that's there right now. But then what can we do with all this excess power that we're going to have when we do, eventually meet the needs locally with wind, solar and batteries? And that's the exciting next step, I think.
Yeah, Justin, what are you guys seeing in the pipeline here, and how do you think the market's going to evolve over the next decade or so?
Yeah. So I think what we're kind of seeing an inflection point now. I think there's been, up until really the last year or so, I think the real high renewable penetration has been kind of isolated to kind of South Australia. But now we are seeing this spreading out, particularly Victoria and New South Wales, with a lot of the ambitious plans. And we're starting to see the renewable penetration get up to points now where it's actually, they have big impacts on the system, such that we need to rethink the way the system is designed, particularly in Western Australia as well. They're in the scenario now due to a great solar resource and a lot of rooftop solar and utility solar. They're seeing their minimum load getting to a point now where it's going to be so low that it won't be able to operate a traditional gas turbine. And so that's got the min load problem we're having in WA. It's the same in SA. So what that means is you need to have something, you need to increase the load, and you can increase that load through a couple of ways. Like residential load is reducing, and there's a few reasons, macro reasons for that. But we can charge that additional power, the additional renewable power, into batteries and put it out later, and that's what we're doing. We're going to see more of that. But we're also, to Garth's point, we could be hydrogen production for exporting that renewable energy outside of your traditional networks and to other countries. Or there are, there's plans like, HVDC links from Australia through to other countries, so inter-country HVDC links to use this additional power. Because it's the renewables are at such point now, and Garth talked to us a lot, is that it's so cheap to generate these renewables that it makes sense to be able to use them in other ways. And I think the other way to think about this is as consumers, we're changing the way we use energy. The markets are going to be a lot faster and a lot more flexible. We're moving to that 5-minute settlement period in Australia next year, which is really reflecting that. We're not seeing that baseload issue. That baseload is kind of disappearing in SA and WA. It doesn't really exist. But you can't operate a traditional like brown coal or lignite steam generator in these countries because you can't turn those generators off. And we are seeing that those minimum load requirements are really kind of dropping. And part of that is, as consumers, we're changing the way we use energy. We're accessing energy when it's cheap, and we have access to price reflective tariffs, for example. As well as we're not using gas for space heating or for water heating like we used to. We're using heat pumps now. The vehicle fleet's transitioning from traditional oil and petrol or gas, as the US calls it, to electric vehicles, and electric vehicles can charge when they want, right? So you can charge when renewables are high and prices are low. So that idea of just a constant load consumers is kind of disappearing. So it's a brave new world, but that's the world we're moving into.
No, it is. it's a very exciting kind of market to be involved in. I couldn't have imagined where we'd be at even 5 years ago. So who kind of knows what the next 5 years is going to hold? That's for sure. Look, that has been a fascinating discussion. So glad to have had you both today. Insights have been really interesting, and look forward to kind of continue working with you both over the coming years in this really exciting market. So thank you very much both for your time. I think Grant I'll pass over to Grant, who will wrap it up. But thank you very much again.
Thanks, Luke. Thanks, Garth.
Thank you so much. Cheers, Joseph. Cheers, Luke.
Thanks, Luke. And just want to give a big thanks to all of our esteemed panelists for delivering such an informative and really interesting discussion today. And a big thanks to everyone in the audience for joining. With that, this concludes today's program. We really hope you enjoyed it. Have a great day, and you may now disconnect.